And now we got Jonathan Williams. Dun 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 dun. Here's my reference. Ladies and gentlemen, my name is Jonathan Williams, and I will be presenting my project. So first is the sun. The sun doesn't have any major moons, and its density is 1.41 grams slash cubic meters. The sun diameter is 865,370. The sun has two moons. It is Reach 1112 Florence and 90482 Orcus. Then it was named after let's see, after Helios. Next is Earth. Earth has only one major moon, which is the moon. Its density is 5.51 grams slash cubic meters, and its distance from the sun is 12,756 kilometers, and its diameter is 7,917.5 million. It takes over 0.99 days to make one revolution around the sun and has one moon, which is the moon. It was named after the Greek gods and Roman. Next is Saturn. I'm sorry for you if y'all can't see my face, but here's my face, and it cut off on accident. So next is Saturn. Saturn has 82 major moons, and its density is 687 grams slash cubic meters, and the distance from the sun is 886.7 miles. The diameter is 72,367 milliliters. It takes over 29.456 Earth days to make one revolution around the sun. It has 82 moons, and it is named after the Roman god of architecture. Jupiter. Jupiter has 79 major moons. Its density is 1.33 grams slash centimeters, and the distance from the sun is 462.93 milliliters. The diameter is 86,881 milliliters. It takes over 11.862 Earth days to make one revolution around the sun, and has 79 moons, and is named after the king of Roman gods. Next is Mars. Mars has two major moons, which are Phobos and Deimos, and its density is 3.93 grams slash cubic meters, and the distance from the sun is 134.69 Earth years. Diameter is 4,000 slash 222 milliliters. It takes over 686.98 Earth days to make one revolution around the sun, and it has two moons, and is named after the Roman god of war. Venus. Venus doesn't have any major moons. Its density is 5.24 grams slash centimeters. That's cubic meters, and its distance from the sun is 67.214 milliliters. Its diameter is 7,520.8 milliliters. It takes over 243 days to make one revolution around the sun, and Venus doesn't have any moons. It was named after the Roman goddess of love and beauty. Uranus. Uranus has 27 major moons. Its density is 1.27 grams slash cubic meters, and the distance from the sun is 1,784.0 milliliters. The diameter is 31,000 slash 518 milliliters. It takes over 84.07 Earth years to make one revolution around the sun. It has 27 moons and is named after the Greek god of sky. Mercury. Mercury doesn't have any major moons. Its density is 5.43 grams slash cubic meters. Its diameter is 3,031.9 milliliters. Its distance from the sun is 39.599 milliliters. It takes 88 days to travel through. It takes 88 days to travel through space at nearly 29 miles and 47 kilometers per second, faster than any other planet. It has 0 moons. and it is named after the Roman messenger god. Neptune. Neptune has 14 major moons. Its density is 1.64 grams slash cumulus. Its density from the sun is 2,794.4 milliliters. Diameter is 30,000 slash 599 milliliters. It takes over 164.81 Earth years to make one revolution around the sun. It has 14 moons and is named after the Roman god of sea. Next is my dwarf planets. Here's can you see? Oh, you get it. Can't see. Here's Pluto. The distance from the sun is 39 astronomical units, and it takes over 247.4 years to make one revolution around the sun. Made. The distance from the sun is 45.8 astronomical units, and it takes over 306 Earth years to make one revolution around the sun. Haumea. Distance from the sun is 43 astronomical units, and it takes over 282 Earth years to make one revolution around the sun. Next is Ceres. The distance from the sun is 2.8 astronomical units, and it takes over 4.61 Earth years to make one revolution around the sun. Next is Eris. The distance from the sun is about 68 astronomical units, and it takes over 561.4 Earth years to make one revolution around the sun. All right, I'm back. As you can see, so next is the Oort cloud, the asteroid belt, comets, Kuiper belt, meteors, asteroids, and the sun. So Oort cloud. The Oort cloud comes from is ancient gravity from the planet stuck by many ice planetesimals away from the sun. The Oort cloud is made of ice pieces of space debris. The asteroid belt comes from a region between Mars and Jupiter, and it is made of bright rocks and stones. The comets. The comets come from our solar system, and it is made of bright rocks and stones. The Kuiper belt comes from both Aquarius, and it is visited by NASA New Horizon missions. And Pluto are in the Kuiper belt, a donut-shaped region of ice bodies beyond the orbit of Neptune. The Kuiper belt is primarily made of icy objects and dwarf planets and dust and comets. Meteors. Meteors come from inside our solar system. Most meteors are made of cyclone and oxygen. Miners called silicates and heavier metals like nickel and iron. Asteroids. The asteroids come from leftover from the formation of our solar system, and it is made of strong rocky balls, and it's really hot. The sun. The temperature for our sun varies from around 27 million degrees Fahrenheit, 15 million degrees Celsius, and at the core to only about 10,000 degrees Fahrenheit and 5,000 degrees. At the surface, instead, the sun is composed of layers made of almost entirely of hydrogen and helium. Then, a solar flare is an intense eruption of electromagnetic radiation in the sun's atmosphere. Flares occur in actual regions and are often, but not always, explained by coronal mass ejection, solar particles and events in other solar phenomena. Sunspots are phenomena on the sun's photosphere that appear as temporary spots that are darker than the surrounding areas. And that's it for my solar system project. Thank y'all for watching, and I'll see y'all later. Bye.